Hi everyone, we're going to sketch the curve with the given polar equation by first sketching the graph r as a function of theta in Cartesian coordinates. We have r equals 1 plus 2 cosine of theta. So for the first part, basically this problem is wanting you to compare the graphs. So for this one, if I just graph this part first, this is an amplitude of 2, so I'll go here, negative 2 to 2, and cosine starts here. So if you graph this one, that's how that would be. Now, with a 1, that means we're shifting it up by 1. So we're going to go to 3, and this is going to get shifted up by negative 1. So you do the same thing, but you're just shifted up. Whoops. So does our center. Our center gets shifted to 1 here. All right, so let me start again. There we go. All right. And then you just sketch the graph, make it a little curvy, and there you have it. So that's what the graph looks like of r as a function of theta in Cartesian coordinates. Now let's do the polar graph. The polar graph, this is a limison with an inner loop. This number is larger than this number. That means the numbers are different. That tells you it's a limison. But when this number is larger, it means it has an inner loop. It's also in cosine. So I know it's going to reflect over the polar axis here. So I'm going to just assign my values from 0 to pi, which I already did to save time. So I filled all this out in for us, and we can just plot the points. So at 0, we're at 3, 2, 3. I'll put a big, let me do a different color. Big dot there. At pi divided by 6, we're at 2.73, which is very close to 3. At pi divided by 3, we're at 2. And then we're at 1 for pi divided by 2. At 2 pi divided by 3, we're at 0. At 5 pi divided by 6, we're at negative close to 1. So you go negative, you go this way. And at pi, we're at negative 1. So it's here. So the upper portion or of the graph is going to look like this. All right. Now that you have that, you can use the fact that it's symmetric to the polar axis to graph the other part. And you just match everything up. So basically at, let's see, where did we stop at pi? At 7 pi divided by 6. Let's go around this way. Let's go this way. So 11 pi over 6, that matches up to pi divided by 6. So that's going to go to the same value, 2.73. All right, 5 pi divided by 3 goes with this one. So that's going to go to 1, 2, which is here. Then we're going to go to 1 for 3 pi divided by 2. So here it's coming in. At 4 pi divided by 3, we're at 0. So now we go back to 0. And then at 7 pi over 6, that matches up to 5 pi over 6. So now that's where you're going to go negative 1, close to 1. And then at pi, we're at negative 1. So it closes up right there. And that is your graph. We started here. And if you went around the circle, we should have gone this way, but it's easier to look at it the other way. There's your limison with the inner loop. Thank you. Have a nice day. Bye-bye.